Welcome to the Sconsit Beach Preservation Fund, Town of Nantucket.
Yeah.
Joint effort.
Okay.
Nice to see you.
Good to see you, Jamie.
JB Pelsier, he's the president
Nice
of
to meet you.
Fish Tech. They're our installation company based out of Daytona, Florida.
Okay.
Guys are doing a great job, pushing through some adverse weather. Not today, but you know.
Oh, I bet.
So.
Being from Florida, how do you feel being up here?
Feels a little cold.
Yeah.
A little bit.
Have you done a job like this before in this
yeah.
kind of weather?
Pretty close.
What kind of work do you normally do?
This is what we do is coastal restoration. Canada, Hawaii, you name it, we've been there almost. South America, Florida, Alabama, Mississippi, Louisiana, Texas.
How is this different from other places, other things you've done?
It's not a lot different when you look at the basic dynamics to it, other than you have a bluff that's much taller than what most people are trying to contain.
Right.
And the vertical height of your bluff is really the difference. You know?
Yeah.
So we're dealing here with two issues. You're dealing with, number one, storm surge issues, but you're also dealing with runoff issues. So you're getting erosions on both sides.
So how long have you been doing this kind of work?
About 15 years now.
Yeah. How'd you get involved in it?
I met a dredger.
Yeah.
And the dredger introduced me to this thing called a geotube. Anyways, when I got involved with the industry, we filled geotubes for containments of stuff that we can't get to the water. We usually use what we call polymers and add it to the slurry that's going into the geotube so that it'll get the material to lump together and dewater and fall out of suspension. Now, from dealing with that for a few years,
What would they be trying to use that for?
Paper mills, any kind of industrial application where you got material that you just need to get rid of, but you have no way to get it to kind of stick together and dry out to truck it off. So we put it into the bags kind of contain it, and the polymers get it to stick together, and then Mother Nature will dry it, and then we cut it open, put it in dump trucks and dispose of it. So 90% of what you see in the geotube industry is all into watering. It's not into coastal. Now the coastal is the smallest use for the geotube, even though they've been installed all over. It's just kind of a niche.
It's a niche, right? It's
a niche.
Right.
It's a little different filling them with sand, building structures out of. Normally we don't care what they look like or where they are. Throw them on the ground and just shoot them, and they're sacrificial. This is a little different because this becomes the product in the end.
All right.
How long is this thing, first of all?
Let's get up out of the sun a little bit. It's going to be 900 feet tall total.
Long.
Yep. It's 3 tubes stacked on top of one another in a tiered configuration, and so the lowest one starts at elevation 0, meaning no water.
Okay, have we put one in yet?
So the first tier is buried underneath the scour apron, and you can see we've done 3 out of the 4 second tier tubes, so we've come down 700 and
there'll be one more on top of that.
That's right. You can see there's a conveyor system that's hanging over there. That's at 99 Baxter. There's another one that you can't see at 87, but that's where we're delivering the sand from. Comes down the face of the bluff, then gets pushed around, and basically we'll build a template on top of the entire system, so you won't be able to see the geotubes. This is the trench that we've dug. This is the water source. So they're pumping about 2,500 gallons per minute as part of the slurry, which is the delivery system for the sand into the tubes. And
wait, I don't understand. You have to use water to...
You have to use water. You pump, so the water starts here. This is the supply for our water source. It goes through these 8-inch pipes,
yeah,
up to that pump right there, and then separately you dump sand into that hopper. It gets mixed at the pump, comes back into a tube, and that's where that's how they fill the geotube.
How does the water get out of the tube? Does
it just weeps out.
Oh,
so the mesh is
it's a mesh kind of.
It's a geo mesh, so it's a it's a poly product.
I see. Okay.
Right.
And that's what that is. Okay.
And so we need a big enough trench that when you're pulling 2,500 gallons a minute, that you're not depleting the water. And this trench here is tidal, so it'll come up and down with the tides.
One in the middle, Pat. One on each end. Just come in like 15 feet. Put a strap. That good with you, Jamie?
So why this spot right here? I mean, is that the end down there, right where I can see the
Yeah, so
end?
the end is just kind of right around the property line between 91 and 87 Baxter Road. So I think it goes just a little bit south of that. And basically this stretch of beach, there was different applications in front of the Concom, in front of the state, and I think they range from 15 to 900. 900 is the most endangered part of Baxter Road relative to the top of the bluff.
All right.
So that's
the reason.
The stretch, yeah.
What are the chances of coming back and doing more, going that way?
Hopefully,
I mean,
pretty,
for those people down there that are in jeopardy.
Yeah, I mean, the problem doesn't
possible?
stop right there. It's
Yeah.
just, you know, the most extreme right here. So,
Right.
So, you know.
But it is a problem down there too, though, right?
It is, absolutely.
Okay. So how do those people feel about not being included in, do you know?
Well, I mean, I don't want to speak for those people, but I think that the general concern for, you know, the safety of Baxter Road and the homes up there is pretty intense, and
So
that,
it's
they'd like
everywhere.
to see something done.
Where do you get all the sand from? Where's the sand come from?
So, you know, okay, interesting. So when you dig a trench, we installed the bottom tube here, which is basically going to live below the beach. We displaced some sand, so that one got filled with the beach sand.
Okay.
Everything above ground here, so the second and the third tubes, that all gets filled with the pit sand. So we're using 50% from Reese's pit and 50% from Holgate's pit.
Okay.
And then the sand template all comes from the pits as well.
Now, do you have to replenish those pits? How do those pits, I mean, at some point you're going to take most of the sand that's in those pits, right? Is it possible that you could?
Well, I mean, so this job, for example, this project is going to require 30,000, plus or minus 30,000 cubic yards of sand from the pits. And it's my understanding that those pits have somewhere, well, in excess of 500,000 cubic yards. So, you know, yeah, they're not forever.
Right.
But they're for a while.
Has any concern, that's the only thing that I've heard so far is what happens if all the sand is taken out of those pits? I mean, I can't imagine, my thought is, I mean, why can't you get sand from anywhere? I mean, where we live.
Well, you can. I mean,
Is there a reason why you took it from those pits and not from the ocean?
Yeah, I mean, a dredging project is a much bigger project.
Much more
It
expensive.
requires the Army Corps. I think that there's probably a tipping point relative to, okay, well, if you're doing a huge volume of sand nourishment, I think dredging makes a lot of sense. I wouldn't consider this a huge volume dredging or nourishment project, so getting it local at this point is what makes sense.